Yes, we are back again, and I believe we know that we've done basic laws of indices where we use the laws to simplify some expression, and at the same time we also did product law of indices where we also use what the values in parentheses or in bracket to also what expand and simplify somewhat expression, algebraic expression and non-algebraic expression. Now we are in what? Indicial equations. Now, this particular subtopic under indices is very important because most formulas in mathematics are basically rooted in what? Indicial equation. Those complex formula, if you check very well, you will see them in this form. You could see some formula even as simple as power. You say power is half mv square. E equals to mc square. You have what? In integration, you have several equations that has to do with your indicial equation. And if you don't understand this, you begin to look at the topics either from your physics or any other subject. From the topic or the equation alone, you look at it as if it is difficult. But if you have a good knowledge or sound knowledge of this, when you see an equation that has to do with what? Exponent or power, you won't see it as anything because you've what? Acclimatize yourself with what? Equations like that. So on that note, I will call our attention, our grade 10 student around grade 11 and 12. Even if you've done this before, you still need to understand it better under us. So give it a rapt attention and let's see what we have. Though there are several tough questions that are in this form, but we have to start with what? The easiest, which will lead us to the what? The tougher ones. And if we can able to understand it, demystifying those ones will be as easy as ABC. Now let's go. Solution. We have what? How many questions? 5 questions for us to do as example, and we have 2 questions for you to do as your trial or test. Do it and drop your answer in the comment section for us to see. Now, the first question we are asked to what? Solve this 3x squared 3 raised to power 3 equals to what? 24. Now, look at this. You have what? A number here and also what? A number here. We can what? First of all, say divide both sides by what? 3. So this one will go. You have x raised to power 3. Then 3 here 1, 3 here 8. Then we're having 8. Now, what's next thing? We are asked to what? Solve for x. And we have to look for the what? The value of x. So what do? What we can do is to what? We say what? Take an inverse of this. So what? Take, you can say what? Cube root of both sides. So this one becomes what? S raised to power 3, everything raised to power of 3. Then this one is what? 8 raised to the power of 3. This we take away this. You have x is equal to what? Now, what do we do to cancel this 3? 8. What are the possible divisors? Number that can divide 8 into 3 places. I think we check 2. 2 can go. So we have 2 raised to power of 3. Then raised to power 1 over 3. This, we cancel this. We are left with what? 2. Therefore, x is equals to what? 2. Now, let's check the second question, please. Let's check the second question, please. The second question is what? He's saying what? S is to power minus 2 over 3 is equals to what? 9. Remember, we are looking for x, not any other thing. What do? Usually, you take reciprocal of everything here so that it can knock off this particular power up there. It can knock off that power up there. Don't forget, this is 2. Now, you do this. x, like I say, what, take reciprocal of power of minus 2 over 3 to both sides. That is, multiply both sides by what? My reciprocal of minus 2 over 3. That is x raised to power minus 2 over 3. Now, minus 3 over 2 is equal to what? This one 2 minus 3 over 2. So this we cancel this we can minus as minus is what? Plus. X equals to what? This. Now what do? We have to look for a way to what? Reduce this to where we can cancel the power of the denominator here. So 9 square is same to what? 9 equals to 3 square. Therefore we have 3 square. Everything is to power minus 3 over 2. This one we cancel this. We are left with s is to power minus 3. Sorry, we are left with what? 3 raised to power minus 3. And remember, we said n raised to power minus 1 is 1 over n. Therefore, this is what? 1 over 3 raised to power 3. X equals to 1 over 27. The third question is saying that what? The third question says 5x is equals to 80 x raised to power minus 1 over 3. We have this. Now we have 5, so we have 5x equals to 80 x raised to power minus 1 over 3. So divided by 5, you have x equals to 16 x raised to power minus 1 over 3. Mind you, this minus 1 over 3 does not affect this 16. It's only power of what? X. So we have what? X equals to what? 16 times 1. Remember, n raised to power minus 1 equals to 1 over n. So since this affects only x, so we have what? 1 over s raised to power 1 over 3. So apparently we have x equals to what? 16 over s raised to power 1 over 3. Here, what do you do? Cross multiplication. Cross multiply, student. So you have what? X raised to power 1 times s raised to power 1 over 3, which is equal to 16. Remember, these bases are the same. So you add their power, you have s raised to power what? 4 over 3, which is equal to what? 16. We are looking for x, not 4 over 3. What do? Find a way to what? Take this out. What can we do? How do we do it? We take reciprocal of what? 4 over 3, which will give us 3 over 4 to the both side. So we have what? Take reciprocal of 4 over 3 to both sides. So we have what? S raised to power 4, s raised to power 4 over 3, then 3 over 4 is equal to 16, then 3 over 4. So this will take this out, this will take this out. You have x equals to what? 2 raised to power of 4, because 16 is equal to 2 raised to power of 4. 3 over 4. So this will take this. S equals to 2 raised to power of what? 3, which is equals to 8. Like I said, we're going to do this too in the next video. We try and make sure you do the practice question and drop your answer in the comment section, and as well show your working. See you in the next video, and bye bye for now.